Hey everyone, and welcome back to part 2 of MOAD 4.0, a Kubernetes story. I'm Matt Bradford, joined with Sam McGowan, Senior Technical Marketing Managers for VMware's Cloud Management Business Unit. Now in part 1, we ran through the automated deployment of a Tanzu cluster on top of vSphere, leveraging vRealize automation. This included the deployment of Prometheus and the Telegraph Exporter to start collecting metrics about what's going on. We also created a vRealize operations adapter so that way we can start to collect those metrics from Prometheus in vRealize operations and start to discover all of the different objects that are within our cluster so we can start to manage it. Now in part 2, we're going to run through the automated deployment of the application itself and show you how the vRealize suite fits into that story to help operationalize this application. And just as a quick recap, the Massachusetts Omni Automated Devices Company has adopted a new Deploy Anywhere cloud strategy. This means that they now need to refactor their entire website and their e-commerce site to run on top of Kubernetes. This means that in the future, MOAD will be able to re-evaluate its cloud options, and if they decide to, they can redeploy the entire web application on a different cloud much easier than they could with a more traditional style of application. Now in this demonstration, we're going to show you how the developer can deploy the application through the service catalog. Now they can also trigger the deployment through a GitHub commit. So with this, we're going to actually pull the latest build of the application from GitHub and deploy it onto our Tanzu cluster that we deployed in demonstration number 1. Now unfortunately, MOAD has hit a bit of a roadblock with refactoring the entire application to run on top of Kubernetes. That's because there are a number of business-critical systems that must access the MySQL database for their e-commerce site in order to pull customer telemetry data and get sales data. So unfortunately, these applications just won't run if that database is containerized. But that's no big deal for our superhero cloud admins, as they've been able to deploy that virtual machine right alongside all of the containers that support the e-commerce website. And once the application is deployed, MOAD's VI admins and network admins are going to go in and take a look at vRealize Log Insight, vRealize Operations, and vRealize Network Insight to make sure that we are in fact collecting information about this deployment. So let's now join our developer and check out this process.
So once again, I'm going to take on the role of our development team, and they're going to come into Service Broker and request a new deployment of OpenCart. This time it will be targeted at our new Kubernetes cluster that was deployed. So we'll go in and click request, and we then have our form pre-populated. We can enter a deployment name and description, and then we can actually configure the administrator username, password, and also the database password, or we can leave it with the defaults. So when we hit submit, we create a new deployment, and this is a deployment which is requesting the execution of a pipeline. If we switch roles again and we switch over into CodeStream as the virtualization admin or the automation admin, we can see that we've got the deploy OpenCart Kubernetes pipeline here, and we've actually got an execution running, which is the one we've just requested through Service Broker. If we click in on the details of this execution, we can see that there are a couple of stages here. The first one is to deploy MySQL, and the second one is to deploy the OpenCart front end. The MySQL deployment is a deployment of a VMware Cloud template in Cloud Assembly, and that cloud template is going to install our SQL server. The next stage is to deploy OpenCart, and this will be targeting using Kubernetes tasks, and we're going to pull the configuration down from a Git repository. So let's have a look at the pipeline itself while this is executing. And we can see those stages here laid out before us. So the first stage is the MySQL server. And you can see here that we've selected a task of type VMware Cloud template, and we're going to create one. We've got an API token for VRA stored as a variable, and we're accessing that using this .code here. We're using a deployment name that is based on the execution ID of our pipeline, and this is how we're going to tie together the Kubernetes resources and the traditional virtual machine resources. Our source template is a VMware Cloud template, and we've selected the OpenCart database server here. We select the Cloud template version to grab the specific release of a blueprint that we want, and then the form is populated here with the inputs for that blueprint. Now you can see we're also piping in the OpenCart admin password as an input, and also the username. So the first stage of the pipeline is going to be to deploy that SQL server. The next stage of the pipeline, we've got two custom tasks here to encode the admin password and to encode the database password. This is because in order to create a secret for Kubernetes, we're going to be base64 encoding them, and so we've just got a simple custom integration in Python that's executing a base64 encode. So it'll take the input of the password and have an output of a base64 encoded output. This allows us to create secrets then using our next stage, which is a Kubernetes task. So the Kubernetes task, as you can see here, it's of a type Kubernetes, and we're targeting that Moad test endpoint that we created in the previous session. We're running an action of type create, and then we're using source control as the source of the configuration. So what we've got in our git configuration endpoint is we've pointed this OpenCart git endpoint is a repository on GitHub which contains a folder structure with the YAML files that we need, and each of those YAML files can have variables within them that we can parameterize and replace them. So for example, we're replacing OC instance with the execution ID, or the database password is being replaced with that encoded database password. And if we jump into our GitHub repository here, we can actually see the Kubernetes configuration files that have been uploaded. We have those two secrets files. We've got our service, and we've also got our deployment YAML. And so when we actually look at the YAML, we can see that we've got that parameterization there, so we can replace the OC instance GUID, and we also have that database password, which is the base64 encoded database password, and that allows us to build up our Kubernetes configuration. Similarly, if we look at, for example, the deployment, we'll have the OC instance variable to allow us to have a unique instance name. And there'll be some of the other parameters around, for example, there's the URLs being used for OC instance. We've got the OpenCart username, the database host name, and you can see where we're actually referencing that MariaDB password secret as well. And what this allows us to do is have our source code in Git, and then when the pipeline runs, it will deploy the latest version of the source code. So our Kubernetes deployment will be always based on our source control. So we create the two secrets, the external database connection and also the OpenCart username secret. The next stage we're going to look at is the OpenCart deployment itself, and this is a Kubernetes deployment which deploys 3 instances of the OpenCart container, and so we're creating 3 pods as part of a deployment. These are connected back to the database host, so we're taking an output parameter of the MySQL Server task. Up here, this cloud template, one of the returned properties is its IP address, and we're then feeding that IP address in as the database host to our front end. We're also configuring the OC user, so the username. And again, we're tying it all together with this execution ID. And then finally, we're creating a service, and that service is of a type of a load balancer to allow us to access that Kubernetes application. Once again, we're still targeting that Moad test, We're doing exactly the same task. We're creating from source control, and we've got a definition for the OpenCart service. And the parameter that we're feeding to it is the OpenCart instance, which is the execution ID of this pipeline. So once this has completed, we should, now we've got a completed execution. We should now be able to open up our moad.io URL. Okay, so if we open up our command prompt, we can actually use kubectl to inspect the objects that were deployed as part of this Kubernetes deployment. So we're going to use kubectl kubeconfig moad test, which is the file, the kubeconf file we downloaded in the first part of this demo, where we clicked on the kubeconf link within Cloud Assembly. We're specifying the namespace, which is OpenCart, and then we're saying we want to get the secrets, the pods, the deployments, and the services, which all make up part of this deployment of the application. So if we request that, okay, so we've got two secrets, the database password for the external database and also the user secret. You'll see each of these is identified by this GUID here, and this GUID is the execution ID from CodeStream. So you can see that we've got 3 pods which are running and deployed. You can also see that we've got a deployment which is controlling those 3 pods. So the deployment requests that it wants 3 pods available, and there are 3 pods available. And then we've also got a service which is deployed. It's a load balancer service, and it's exposing the external IP, which is from that range that we supplied to the Kubernetes cluster that we deployed. So from this, we have all of the components that we need. And with that, I'm going to hand you back to Matt, who's going to have a look at the operational side of this.
Thanks, Sam. This looks really awesome, by the way. So if I click on this page, yeah, everything loads. Wow. This is really cool to see. Good work, Sam. So yeah, I'm going to take the seat of the VI and the network administrators here, and we're going to take a look at this application through the eyes of vRealize Log Insight, vRealize Operations, and vRealize Network Insight. Now, part of the MySQL VM deployment also includes the vRealize Log Insight agent. So this agent is responsible for collecting all the OS and the application logs and shipping those to vRealize Log Insight. So let's jump into Log Insight here and just make sure that we are seeing those logs. So if I go in and if I add a filter for host name and then enter the host name of our virtual machine, so this is that MySQL VM that got deployed. And if I just click search here, yep, sure enough, we are seeing plenty of logs coming in. In fact, 8,100 logs in the last 5 minutes. So yeah, we can safely say this is working. Now, looking at the log messages down below here, we can see a lot of select statements, deletes, so forth. So this looks like all of the various MySQL queries that are being executed on this virtual machine. So this may be a little bit too verbose, especially if we're going to have many instances of this application deployed across our infrastructure. We may not necessarily need this level of detail. However, it's very easy to reconfigure the Log Insight agents. I can actually do this centrally through vRealize Log Insight under the administration tab. I have groups built out for example, for these MySQL virtual machines. I'm looking for virtual machines where the name contains the word MySQL, and that is applying the MySQL configuration, which includes where to gather those MySQL logs from. So I can make that change centrally right here, and I don't have to go back through and alter any of our workflows or anything like that. So that looks really good from a Log Insight standpoint. Now let's move on to vRealize Operations. So as you recall in part 1, when we deployed the Tanzu cluster, we also deployed the Telegraph exporter and Prometheus. Also, as part of that, we created a vRealize Operations adapter, so that way vRealize Operations can connect to that cluster, discover all of the objects within it, plus pull those metrics from Prometheus. So we're now returning to vRealize Operations to take a look at our cluster now that the application has been deployed. So I'm just going to do a quick search for our moad test Kubernetes cluster. And in the summary page here, we can see there are no alerts for this cluster, so everything's actually looking pretty good. Now, if I go into the metrics, this is where we can view all of the objects within that cluster. So we have our cluster right here, we have all of our nodes right up here, and then all of our namespaces. And so right here is the brand new OpenCart namespace that we just created. So if I expand this out, I can now see the OpenCart deployment and the OpenCart service here that was deployed. Now, as part of this deployment, like Sam said, there are 3 pods within here. And then each of those pods contains a single container. Now, let's just take a moment to talk about the Telegraph exporter in Prometheus for a second. The Telegraph exporter is deployed on each of our Kubernetes nodes and is responsible for connecting to the Kube API to pull metrics about our pods and our containers. It then exposes those metrics to Prometheus, so every couple of seconds Prometheus is going out there and scraping those metrics from each node exporter. vRealize operations then connects to Prometheus every 5 minutes and pulls those metrics for each of those objects and applies the metrics to that object. So for example, if I click on my container right here, and if I go into my metrics, I can see the various vRealize operations metrics here, but there's also a special drop down for Prometheus. So these are all the Prometheus metrics coming from the Telegraph exporter. Now, if I had different Prometheus jobs running, I could also see those jobs listed out here. So if I expand the Telegraph exporter, now I can start to see all the metrics that are being collected by the Telegraph exporter. And for example, this CPU usage in nanocores. Now, as a VI admin, nanocores is kind of a strange unit, right? I'm used to seeing CPU in terms of percentage or in terms of megahertz. But nanocores is the percentage of 1/billionth of a CPU. So that gives you an idea of the scale that's being used to measure these microservices. As you can imagine, if we were to use percentage of CPU, we might have an awful lot of floating point numbers that could just get rounded off, and therefore we wouldn't have an accurate representation of the consumed CPU for that container. And then scrolling down here, we can see how much memory this container is using. Plus, we can see how much storage is available for this container to consume. So you can see where all of this will be very useful for troubleshooting, not just at the vSphere level, but also all the way down to the container. Now, as you can see, obviously we're just looking at the Kubernetes objects here, but one of the great things vRealize operations can do is, again, we can map that Kubernetes constructs back to the vSphere infrastructure that it's running on top of. So I'm going to expand out my nodes, and I'm going to go to the details of this node. And now I can see the node. These are all the pods that are running on this node. But look here, there's this connection back to this virtual machine. So vRealize operations understands that this Kubernetes node is actually this virtual machine right here. So I could even expand this out even further, and I can see the ESXi host that that virtual machine lives on. And this can be very important for things like the troubleshooting workbench, for example, which actually leverages these relationships. So if I were to have an issue with one of my containers, I could actually go into the troubleshooting workbench and expand my scope out far enough so that way I can look at the container and I can look across the node and the virtual machine and the ESXi host and maybe even the vSphere cluster that that virtual machine is running within. And I can look across all that for anomalous metrics or configuration changes. This also comes into play with metric correlation too, so I can look across that entire scope of objects to see if there are any metrics that correlate, whether positively or inversely correlate with that given metric. So now I can start to really hone in on where I need to focus my troubleshooting efforts. So now that the application's deployed and running, let's just check this virtual machine. And first, I want to see what our CPU demand is. So how much CPU is this virtual machine asking for? And we've got a high watermark of about 9% here. So plenty of headroom there. And let's just quickly check on memory. So go down here, scroll down to usage. And yeah, 15% memory usage for this virtual machine, which is really, this Tanzu Kubernetes node. So everything is looking really good for running this application at this point. So let's move on to vRealize Network Insight and see what sort of information we can gather there. So let's start off by taking a look at our MySQL virtual machine. And so I'm just going to put the name in here. And then for the time range, I want it to be relative to now. So just leave that as it is. And if I click search, we'll find this virtual machine, and we've got information like what VLAN is it on, what's its IP address, where does it live. So if I click on the virtual machine here, I'll be able to see the topology of this virtual machine, right? So everything that's kind of related to it. But then also the traffic flows. So vRealize Network Insight is studying traffic coming into and going out of this virtual machine. And you can see we've got 21 flows here. So if I click on the flows, we can actually get the details of what's happening. So this is showing me all the flows across all ports going from and coming into this virtual machine. But let's narrow this down to just look at the MySQL ports. Now, up here at the top, I can see traffic from one of my Tanzu Kubernetes nodes to our MySQL virtual machine. And so this is what I would expect to see, and just shows that everything is working as expected. However, down here, this looks a little suspicious. I'm seeing traffic coming from Russia to our MySQL VM. Now, MOAD doesn't have a Russian office, nor do they do business with Russia, so this is definitely cause for concern. And then scrolling down, we can look at more traffic flows. So I see traffic coming from another one of our Tanzu Kubernetes nodes here. And then down below, even more traffic coming from Russia. I've got 2 different IP addresses here as well. So definitely something I want to take back to my security team and make sure that we lock this down, because there's no real good reason why that traffic should be flowing to our MySQL VM. And so that takes us to the end of this demonstration here. We've gone and deployed our application. We've logged into vRealize Log Insight to show that we can collect logs from MySQL, as we saw with the MySQL queries in Log Insight. We've gone into vRealize Operations and made sure that we're able to collect metrics for each of the containers that this application runs within, and make sure that we've got enough CPU and memory and disk available to run those applications, as well as be able to see the vSphere infrastructure that those run on, so we can start to do some troubleshooting if we need to. And then finally, with vRealize Network Insight, we're able to see traffic flows from our Tanzu Kubernetes cluster to the MySQL virtual machine, and detected some anomalies that we want to take care of. So thank you so much for checking out this demonstration today, and stay tuned as MOAD continues down their Kubernetes journey, and see how the vRealize suite can be leveraged to help them along the way. Now, if you want to get more information and see more of the vRealize suite, then check out pathfinder.vmware.com. Pathfinder will allow you to explore vRealize Log Insight, Network Insight, Operations, and Automation. And within each of these products are paths, which cover the core use cases. So for example, here in vRealize Operations, we could dive deeper into Kubernetes management, or even look at intelligent remediation. Each of these paths will start with a level 100 overview and then dive deeper into 200 and 300 content, plus give you hands-on experience. So do check out pathfinder.vmware.com today. So thanks again so much for joining us. Hope you all have a fantastic day.